out. If you remember the example from yesterday, we wrote it out as a sales project or a sale problem. We were given two values, a sale price and the quantity sold. These are all modeled after quadratics, which means you're looking at two terms because you're going to multiply them out. So if I start this one up, I know that they're selling 200 pairs of shoes.
200 minus 2x.
So we have 200 shoes. I'm just going to start it real generic before I start filling everything in. And I know that they're selling them at $60 each. I know this is a quadratic because I have the quadratics whole setup here. If I multiply 200 times 60, that's going to tell me my overall revenue. If I just sold that right there. Do you agree? Now they're changing it up a little bit. They're changing the variance of it. If I take this and I increase my sale price by $1, each time I increase it, I sell 2 fewer pairs of shoes. So as I increase an X value to the 60, I subtract 2X this way. Now this allows us to create a quadratic. Yes, sir?
But like, I don't get how the X in one side give me like money and on the other one a pair.
It doesn't say that. It says for every dollar. Oh, I see what you're saying here. If you increase it $1, you sell 2 less.
Yeah, but like X is 1 and that X is like dollars and that X is pairs of shoes.
Okay, but here's what I want you to think. If I increase it by $5, how many shoes less will I sell? 10. It's 5 times the dollar amount, 5 times the 2 less. It's just the amount being multiplied. Sometimes if you think of it, it's just $1. There's other problems that we have that it might be $5. Okay, so it'd be like a 5x. Yeah.
So,
Oh, okay. So at this point here, what you're trying to figure out is that you get a quadratic. With quadratics, if I multiply this out, which don't ever multiply these out, you'll notice that your x squared term becomes negative. Does everybody agree on that? The x squared term becomes negative, so it's going to look like this. I also know that at some point in time, it's going to cross the x-axis. Do you agree? If I look at that, if I wanted to figure out where it's crossing the x-axis, all I'm doing is finding the zeros, which is something that we have done throughout this entire chapter. When you're trying to, give me 1 second, okay? When we're trying to find our zeros here, just like we did back in 5.2 and 5.3 and all, you just set each of these individual terms equal to 0. So this 0 would be at negative 60, and this 0 is at positive 100. Add 2x, divide by 2. So I have a 0 at negative 60, and I have a 0 at 100. Set them equal to 0. Don't try and visualize it. Just go 200 minus 2x equals 0. Solve for x. Don't try and do it in your head though. Yep. Yep.
I'm sorry, I'm so confused on how you got like the 2x and the x and why you put them in those 2 spots.
You're increasing $1 to the sale price. You're decreasing 2 sales to the total shoes that you sell. So if you have 2 separate parts going on here, 2 terms. Sale price and units sold. If my sale price is 60, I'm going to sell 200 shoes. If my sale price is $1 more, I'm going to sell 2 less pairs of shoes. If my sale price is $5 more, I'll sell 10 less pairs of shoes. For all the increase in price, less people are going to buy them. That's what the balance is going here. Okay? Yes, ma'am.
So it does matter, like, say, like, instead of putting, like, 200 minus 2x, you put, like, 200 plus 1x? Like, that matters, right?
It does matter at the very end, it does matter. And it does matter because your zeros become backwards.
Okay.
Okay? So now, like I was saying, those are 2 ordered pairs. Negative 60, 0, 100, 0. If I find the midpoint of there, that's going to give me the halfway where that happens. What's negative 60 and 100? What's half of it?
20.
Negative 60 and 100. So this midpoint, this part here, the x coordinates can be at 20 something. Well, to figure out what the something is, go to your calculator.
Wait, where do you get 20?
Negative 60, put away your own stuff so you can listen better. That might help. Negative 60 plus 100 is 40. What's half of it? 20. That's where I got 20 from, guys. It's the midpoint. Welcome back to geometry. Okay? Go to my calculator. At this point, if I go to my calculator, I can put this in exactly the way that it's written, within the two terms. It works. 200 minus 2x, close it, open it, 60 plus x, close it. I don't care what the graph looks like. Think intuitively of what curves do. This is a parabola. It's up like a cup or it's down like a frown. It crosses the x-axis. Okay? Yesterday we talked about how to find that maximum value via your calculator. So if you want to spend all day moving your windows around to try and find the curve, that is fine. It takes a long time to do that. Some of you might have realized that yesterday. What I'm trying to show you here is a more direct approach to use things that you guys have done. You guys all did quadratics at some point. We've used zeros, okay? We've done that. What I'm looking at here is just making it work easier for me. So if I put that in there, obviously my window right now is all sorts of messed up. I can't see the curve, okay? So if I just go right to my table, find 20 for x. What's y? $12,000 or something like that.
Yeah, 12 is in the
12,800. So if I charge $20 more, my total revenue would be 12,800. It's not telling you that your sale price is 20. Think about what it's telling you. It's telling you that your 20 is the value of X that you increase. So your overall sales price then is how much? 80. That's how that works. Okay. It's the same thing with the next one. We were talking about cameras. When you're looking at cameras, you've got sale price of $680 and you're selling 70 of them. For each decrease in price, you sell more. So if your sale price was the 680, you're selling 70 of them. Your sale price is 680. For each decrease of $20 to the sale price, what do I write? Minus 20x. You're ahead of me. Did you put the 70 first? Which is fine. Okay. And then if I sell it by $20 cheaper, how many more will I sell? 5x. And I do the exact same thing. I can walk through, I can go to my graph, put that in the calculator. I can find the top of that curve by messing with my window. It takes a while to do that. It's one way of doing it. All I'm suggesting here, guys, is that if you've got these money style problems, it's a zero you're working with. You're working with a quadratic, set it equal to 0. As you go through, you'll have 2 spots. You know the curve's going to do that because they all do that.
Wait, is 100 the follow-up to 99?
No, it's just the one after it. Sorry.
So I guess it kind of is like
Yeah. Okay. So again,
Could you do the same thing if it was set up in the ax squared plus bx plus c?
if you want to, yeah, you can do that. And at that point in time, I wouldn't try to factor it. There's no way. I could use quadratic formula. All right. You'll find with the quadratic formula, that's going to do is get you your zeros, but you still got to find that maximum. You know what I mean? So you're still going that way. So here, I have the two zeros at, was it 34 and negative 14, I believe?
Yeah.
If I set those both equal to 0, what's 34 plus negative 14? What's happened there? 10. All I'm doing there is find the midpoint. This value is comma 10 something. So if I decrease the price by 10 times 20, so if I cut the price down to $480, I will maximize my sales. That's all this is telling you. That value of 10 is the value of X that will generate the most sales. That'll be the maximum part of that curve. Whatever the Y coordinate is in your calculator for that point at 10, that's how it works. It works really nice to do it this way when you don't have crummy numbers. When you have crummy numbers like the next one with the Big Bertha cannon, you want to do something a little bit different. You're going to want to try and look at your curve. You are going to want to try and see if you can find it in your calculator because it becomes a little bit easier to identify what's going on. Okay? So if I look at the Big Bertha problem, they're giving you the model to start with. That goes very
Wait, Mr. Murphy, I have a question about the other one. Okay, so what does the 10 have to do with anything?
That's the X value. That is the number. That value of 10 is what goes here that maximizes your revenue.
Okay, so would you put the 10
Hold on.
into the 680 minus 20 times 10,
Yeah.
and that would be your answer?
You'll get your answer. But like I'm saying, if you put that directly into your calculator, oops, don't worry. If I put this directly in my calculator, these two terms, and I go to my table, it'll tell me what the Y value is for 10. It
And
does it.
Like the Y value is the answer.
Yeah.
Okay.
Wait, the Y value is the answer.
What does the
Yeah.
Y
Okay.
value mean though in the
It's,
problem?
this is the total maximum revenue. What's the most money you're going to make? When X is 10, you make the most money.
Thank you. Okay.
That's what that means.
So I'm selling shoes for cameras for $480.
Yep. More, because when you sell shoes for when you sell cameras for $480, you're going to have 120 people buying them. When 120 people buy 480 cameras, you get some big number. That's what that is.
Okay, then-
That's what you're doing. That units, think of this as your units being the units. 20 times some amount of units, 5 times however many units.
Wait, so how much do you charge for it? Just like,
Well, if the sale price was at 680,
oh, is that, and then you plug a 10 into that, and then
Yeah.
okay, thank you.
that's all it is. That's all it is. That's how it works out. Yes, ma'am?
How do you find the maximum monthly revenue?
That's the value of X.
So $10?
No, X. What's 680 minus 20 times 10? There you go. That value of X is the midpoint. You're solving for this X value. Where does this value give you the biggest Y? At that value is the peak of the curve. Okay? Yes. Yes. How are you guys?
Are the word problems going to be mostly like sales stuff? Or are they going to have, should we know the equation?
No.
For like the lesson?
I'll get to that when we get to those. I won't make you guys memorize that. I'll give you the model. I might just give you the blank model and fill it in, but I won't make you have to memorize it. When you're looking at this, this is a type problem that I don't have terms right off the bat to be able to find my zeros rather easily. It's kind of a pain. Could I find my zeros with this? Yeah, I could factor it out and set things equal to 0 and do that, but it's not easy. What I'm going to do here is look at something, again, intuitively of what is going on. The cannon here is starting someplace. If I'm going to start a distance to fire a cannon, wouldn't my original distance starting point be at 0? I'm shooting from the ground and it's going out. So the cannon is being shot at from the origin here, and it's going kablooey there. Okay? I'm not worried about the curve itself, looking at any of it being negative. It's starting someplace and it's ending someplace. It just so happens the start and the end spot are on the x-axis. It's the zeros. Okay? I have a function. They gave me the function. I have a graphing calculator. I gave you the graphing calculator. Negative 0.0196x squared plus 1.37x. I'm going to my graph. And this is where you want to start to get creative and think about cannons. Is a cannon going to shoot negative? No. Is a cannon going to shoot 500 miles up in the air? No. Is the cannon going to shoot 500 miles out that way? No. Yeah, it's probably be a big rocket. So what I'm going to do here is just leave my x minimum at negative 10 for right now. I don't really need to worry about that. My x maximum. I'm guessing this cannon probably shoots more than 200 or 20 miles. Maybe, let's set it to maybe 100. Okay? We're just trying to see if we can find the curve. My y maximum. Again, I don't believe a cannon's going to shoot anything 500 miles up in the atmosphere. I think the top of the atmosphere is what, only 50 miles up? I think so.
7 miles.
So I'm just going to set this to maybe 50. And then again, I'm just going to hit and look at the graph and see what happens. All right, cool. It works. Everybody see that? So I know that somewhere out there, it's going from a positive value of y to a negative value of y. Because it crosses the x-axis. Here y was positive, here y is negative. You okay with that? So I'm not going to do any math, but hit my table and look for a wire where y goes from positive to negative. Still going? I think I'm past it. Yeah. I'm going to pass it, right?
All those areas.
Yeah.
69.
Between, yep, see how it switches between 69 and 70 miles? It goes from a positive to a negative. Think about what that means. Again, the curve is coming across, staying positive. All of a sudden, it has to cross 0 to become negative, doesn't it? So can I say that this spot right here is about 70 miles? Just for a rough estimate?
Is this allowed on the tests and stuff?
This is how I would solve it.
Okay.
Because what I'm looking at here is how far could it fire a shell? About 70 miles. You guys know how far that is? That's shooting a cannon from here and it hits Lake Michigan.
Oh my gosh.
That's about 70 miles.
How does that even work?
How would you even aim that?
You point east.
Just point it.
Now, what happens then, again, the next part of the problem, it says, what would the maximum height be? We're talking here horizontal distance, right?
Yep.
This is vertical distance. Horizontal is your x value, vertical is your y. So what happens halfway between 0 and 70? 35 for your x value. What's it going to kick out for your y value then? Like 24-ish?
23.9.
Okay. Yes, yeah.
So would it be 35 for x? Wouldn't you have to divide by 2?
Yes, that's exactly. Because I know I'm starting at 0 and I'm ending it at about 70. Okay, so that's what I'm looking at. I'm thinking intuitively of what the cannon is doing. It's starting at something, it's going over here.
Okay.
There's another problem in the next section, 5.5, where they have she's throwing a shot put. The shot put problem is different because instead of starting at the ground, it started at 5.5 feet up in the air. Why is it starting at 5.5 feet up in the air?
That's where her arms
Because she's holding it.
She's literally.
She's a short person.
Okay. That's why that is. What's that? I'm getting there. Okay. So,
Wait, is this all
pretty much. I'm guessing that the only problem, oops, go a little quick here. The only problems that I've seen so far today that people have had with the area ones is that you forgot how to solve what the area of a trapezoid was.
I don't know what's all
The area of a trapezoid is 1/2
Based on
base, yeah, sum of bases.
I could do the record.
This was the only one that I've heard so far anybody have any issues with. Remember, when you're solving these things out via quadratics, it's going to give you a positive and a negative value. Which one do you want? Positive. You want positive, at least if you're talking about lengths, okay? There are times that sometimes the negatives are what you're looking for depending upon the problem. You got to make sure you just look at it carefully and how you set it up. So here, this is one where you have 70 is going to equal 1/2 of x plus 4 times 4x. We okay with that?
Yeah.
Now, multiplying it out, I'm going to get 140 is 4x squared plus 16x. Everybody see how this is going to wind up with a nice problem to be able to complete the square with rather easily? Yeah. What's x plus 3x? I did. Okay. I just got rid of the fraction, multiply both sides by 2. I'm doing the same thing. You're going to get the same answer.
Where did you get the? Why do you have 4x? Why don't you have 2x?
What's x plus 3x?
There we go. But then you have to
Oh,
find the
no.
2, right? You have to find the average.
Hey, Clay? It's going to be the same thing. It's the same thing, man. If I take half of 4x, I get 2x, right? I'm going to get the same result. I'm going to get the same thing. Trust me. It's going to be the same. All right? At this point, divide everything by 4.
What about 4x? Oh, do you just do?
I forgot what that was. 35, I think. Yes. I can't factor that because I don't know what two things multiply together to get negative 35 that add to 4. So in this case, I can do one of two things. I can do the quadratic formula, or I can complete the square. I would say complete the square because what's my middle term? Even. Yes.
How can I like just get rid of like 4? Just like that.
If I factor out a 4, I got all this times that. Divided by 4. What's 0 divided by 4?
Oh, okay.
So now you get x squared plus 4x blank equals 35 and a blank. Half of 4 is what?
2.
Square it.
4.
You get that for an answer after you've set it up. Okay. Now, at this point, I don't want the negative value, so I don't want to do the negative 2 minus the square root of 39, because that'll be even more negative. I'm just going to leave my only answer as negative 2 plus the square root of 39. And that's what x would have to be to make that work. Right? I think there's a problem coming up here when you use the quadratic formula in 5-6 that you want a negative numerator because you're dividing by a negative absolute positive. So we'll come across that here real quick, I hope.
That's supposed to be a 2, right?
Yeah. Like I said, when you're doing 89, it blends back to what another example was in the book. In this case, the model kind of sucks because it doesn't tell you exactly what you're supposed to do. You're supposed to set it equal to 80, and you get like 25 miles an hour. Yes, sir?
What does show that in snow conditions, the driver cannot safely round the corner? Like,
It would say-
It doesn't say anything about rounding corners in before.
It talks about, bless you, there's a model of a quadratic of how you can figure out what's the fastest way to go, what's the fastest speed you can safely go around a curve. That's what they did in that example before. It's a crummy problem because the model wasn't set nicely, okay? When I have stuff for tomorrow, it's nicely set, so don't worry about that one. I want to look at 90 though.
Can you just like skip it around?
Again, this This mirrors the same generic setup as the cannon shot. It tells you it's a negative quadratic. It's being thrown up and over. It's starting at a height of 5.5 feet, because you're right, she's holding it 5.5 feet above the ground. That's where that comes into play. So as you go through this, they want to know how far did she throw it? Well, again, you're starting at 0, because it's behind the line, and then you're throwing it so far. Well, she's starting her throw at 0, 5.5 for an ordered pair. That makes sense? The curve is going to go like this until it hits the ground. That is at a 0. So again, this is just a crummy quadratic that's asking you to find the positive 0. That's all it's asking you to do here. This is going to come back this way, cross over here, but I don't want the negative value. I didn't want to drop it behind me. I'm not going to win a gold medal. If I use quadratic formula here, I get, what is it, plus or minus b squared, so it's 1 plus or minus the square, or opposite, excuse me, 1 minus 4 times negative 0.0241 times 5.5, all over 2 times negative 0.0241. And here's where I was talking about, when you get down to the end of the problem, you're going to have some crummy number up top divided by some negative value down here. I want to get the positive distance. So am I going to use the plus root, or am I going to use the minus root that's on the top? I want to use the minus root. I want to make the numerator negative, because I'll have a negative divided by a negative to give me the positive. That's where it gets a little, this is like the hairy part here, trying to remember what exactly are you looking specifically for. Well, I'm throwing it a positive distance, so I want that when the division is done, I want this positive 0. All right, I want that positive side 0. Again, it's just crummy looking function, plug and shove quadratic formula, guys. All right? They're giving you the model, use quadratic formula. You could complete the square if you want. I think I saw somebody try to do that, and it was like crazy.
Couldn't you just put that one into your calculator and twice give you the y and the x, or would that not work?
You could go in the calculator like that as well. You'll see where it crosses. It's going to give you a rough estimate. Like it might say, you might notice that it might happen. I don't know what the answer was. Let's say it's between 22 and 23 feet. You don't know how many feet it was, because I'll ask you round it to the nearest 100. So you can guesstimate and maybe get it right, or you can just use the quadratic formula and get and round it correctly. Is that right?
Will the test tomorrow be the non-calculator and the calculator?
Oh, it's all calculator. I'm not taking it away.
Okay.
Except for you. No, I'm just joking. Joking. You got excited, so I just figured to say you. All right. And the last part here, we started talking about a little, we discussed this a little bit towards the end, what it meant to be the difference between dropping something and throwing something.
You broke it.
We're likely to break it.
Okay. Now, the difference between those two is that when I'm throwing it, there's an initial velocity given to it, which gives it that curve. All of these types of initial velocity style problems all are modeled the same way, because we live on Earth and gravity is something that you can't escape. What you're doing here is that this model for gravity style problems, if you need to use it tomorrow, I'll give it to you. I'm not going to tell you what the initial velocity or the original height would be, but this is a generic model. If you guys take physics, you're going to see this again. This is what happens if you're in a vacuum, because in the real world, there's this thing called air resistance and wind and things like that. In the problems you're looking at in 5-6 then, was the first one.
So you give us the formula, but not tell us which is which?
Yeah, if I'm looking at 75, if I'm looking at 75, you're talking about cliff diving. You're cliff diving, and it tells you that you have you're 92 feet up. Okay. You're 92 feet up in the air, and you have an initial velocity, which means you're jumping up. All right. You're jumping up. All right. We did this one yesterday, didn't we? Oh yeah. All right. So if you have your original model, where it was y equals negative 16 t squared plus the original velocity times t plus the original height, you have to take the info from here and substitute in there. The velocity is going to be positive or negative. You're jumping up, it's positive. You're jumping down, it's negative. In the next problem, you're talking about the volleyball. The volleyball is being hit downward. That's why they told you your initial velocity is negative 55. Does that make sense why that is? So here I know that I'm going to get negative 16 t squared plus the 5t, and my original height was at 92. I'm trying to figure out when time is 0. How long does it take me to get to that positive 0? Because on this, again, on this curve, it's just starting somewhere up the curve. You're jumping out and in. So you solve for t using quadratic if you want, quadratic formula, and you're looking for the positive time. Bless you.
Thank you.
Okay? Does that make sense?
Will something like this gonna be on tomorrow?
Sure, why not?
But like,
Absolutely.
then, like, do we have to know the formula of the?
Have I mentioned that yet?
Yeah.
Okay, just wondering. Yeah, but
I got some stupid number like -5 plus or minus I root 5.
shouldn't have an imaginary here. I bet you I know what you did. You wind up here where you have opposite of b, so you have -5 plus or minus the square root of 25 minus 4 times negative 16 times 92. I bet you did multiply by negative 16.
That's why I got radical 25 minus 5, 88.
What's minus a negative?
Oh, -4. Oh.
Okay. So I believe in this case, I think the radical becomes 5913 when you multiply that out. So here you get -5 plus or minus the square root of 5913 divided by -32. This mirrors what we just talked about a second ago. See how I'm dividing by a negative? What do I want my numerator to be then? Negative. So am I going to add the square root of 5913 or am I going to subtract it? I'm going to subtract it. Because someone could tell me, oh, well, you're going to be in the air for -5 minus the square root of 500 or 5,913 divided by -32 seconds. And I'll say, what? But if you do the work, I think it's like 2.5 seconds. Bless you.
Yeah.
It's like 2.56, I think. Everybody knows that's 2.5 seconds. It's like the 2.5 seconds of your life you're not going to get back right now.
Why did you do that to me?
He's trying to be funny. Yes, ma'am. A couple of them. I don't know. Depends if you know how to do the other stuff.
If I do none of these, will I still succeed on the
No.
test?
So to get to 2.5, you literally just take -5 plus root 5, 5913 over -32.
No. You have to -5 minus 59. The square root
Solve
of
that.
the square root of how do I solve that?
Yeah, I don't.
I use
a calculator. Get that, but I don't know why it's running.
How do I do that? All I do is this. Alpha y equals -5 minus the square root 5913 over -32.
You You could literally do that.
You rather have.
I've been doing it.
I'll ask you for it, I'll say round to the nearest 100.
Do you have a real answer?
Yeah, like I was just saying, I don't know what that is in time, but I know like 2.5 seconds is like, you know, you try to approximate how long to fall from 92 feet is like 2.5 seconds. We just proved it.
With no
Did they
wind resistance.
try it?
Well, the roof is only like 30 feet. We'll go time you off that if you want.
So it'd be about like,
No, it's
Okay.
less than 2 seconds.
it'd be like one.
76 is an awful model. Don't worry about it. I forgot that was there. The volleyball one, the volleyball problem mirrors the same idea of what we just did. The only thing that's different is that the initial velocity is negative, okay? You do the same thing. There's a lot of words there for only needing to know that you're starting 10 feet up and your velocity is negative 55. It's a whole lot of mumbo jumbo for that.
So you use the same formula?
Yes, sir.
Okay.
When we get into the aviation or the next couple here, what I want you to notice is, you see how they're giving you the model for that problem. In 78, they're telling you that the length of a runway is needed or whatever is given to you by this model. The equation is that. You don't have to use anything else but that. They're asking you what is the speed if your runway is 2,000 feet long. So what do I set this equation equal to? When you solve for the zeros. Remember, the length of the runway is by some funky, oh, this one's other way around. By some funky parabola.
That's not existing.
All right?
So is the
It's just looking at the curve itself, okay? You're going to have a positive and a negative and positive 0. Well, all you're doing is taking 0.1x squared minus 3x plus 22 and set it equal to 2,000. Which means I'm just going to use the quadratic formula again to figure out what x is going to be, which is this maximum speed to safely land. Otherwise, you go underground and you die. You wind up with 0.1x squared minus 3x minus 1978. You set equal to 0. You're going to have two zeros, just like we had before, a positive 0 and a negative 0. Are you going negative speed?
No.
No!
That would be impressive.
Unless you're doing 88 in a DeLorean.
I get it.
Tell me that everybody else got that.
I agree.
No, it's still positive speed.
I didn't get it.
I know.
Back to the Future. Oh, that was a joke.
You don't know about
Just go to like
There
the
it is.
next Oh, no, back to the future.
And it's like, did they need the car to work?
Slap.
No, it wasn't. The car is a DeLorean. That's, yeah. It's made out of stainless steel.
It's got cool doors too. It's
The
like-
next, now be honest on this next one. Did anybody write out 60 billion to try to do the problem?
Don't do that. I didn't try. I didn't even try.
It tells you, the amount, this is the dead giveaway here. It says the amount A given in billions means this is 51 billion. Don't put all those zeros in, guys. It's just a big pain to try to do it then. You do the same, you do the same thing. You're given some specific model, and you want to know when that model equals 60. Set the side equal to 0, use quadratic formula, and get a positive solution. All right? That's going to give you time, okay? Where t is the number of years since 1989. So if your t value winds up being like 7.2, it's like 7 years after 1989. Well, what's 7 years after 1989? 6. If it's 12 years, so that's the kind of thing you're looking at. All right. Last year, Leaf thought it would be funny when we did this problem. He figured out the day it wound up being. He figured out the percentage of, this is the decimal. Figured out what decimal 365 days, what day of the year it was. So his answer was like June 3rd. Yeah, he was just being goofy. He was trying to be funny.
Oh, brother.
All right. Now, the idea here, and the next one, notice what it's missing. And the last model, what is it missing? What's the initial height? Is there a height that it starts with? No. So what's your initial height? So the lava is starting from the ground, shooting up. All right. It does start below ground, I know, whatever.
Is this like
Actually
right now,
Now-
our time to fix some of these answers that we didn't get?
Oh, I'll get this tomorrow. I'll give you time to fix these because I know this stuff isn't the easiest in the world.
Okay.
Now, when you're looking at the model here, the model itself it mirrors again that initial velocity style problem where it is negative 16 t squared plus your initial velocity times t plus your initial height. In this, what's the coefficient of just the t value? 350. So what's your initial velocity? 350. Okay. Your initial velocity here is you're just plucking the coefficient. Now, in order to figure out what the maximum height above the ground is, well, if I substitute in this formula again in my calculator, was it negative 16x squared plus 350x. If I go to my calculator, I really don't see where it is right off the bat. But if I just think about where it's crossing the axis, if x is 0, y is 0. Do you guys agree? Because there's no, if it's 0, what's 0 plus 0? 0. Are we okay with that?
Yeah.
So if I'm starting with this curve, I know it's going to be down like a frown, so I know it's going to do this. I know it's going to cross here. If x is 1, it's negative 16 plus 350. Do you agree? If x is 2, it's negative 72 or whatever plus 700. So I know that this value up here is going to be, I don't know, try 5,000. You're looking for your maximum that way. You're trying to mess around with the values. Use things that you know that you guys used to solve with tables when you're doing linear stuff.
5,000 is too much.
Was it too much? I'm just guessing off the top of my head. All right, so then that way, when you get this, the maximum height, I'm going to use my calculator to find the maximum by left bound, right bound. See how in this style problem, it's a lot easier to do that as opposed to the other ones, where I would get the 0 and I'd work my way out.
I still don't know like why in some problems you use like the maximum thing and the table